Good evening, everyone. Today, I'd like to show you how you can deploy a contract using Foundry. We know Foundry is pretty good at doing a local test or doing a test on forked blockchain. But today, we are going to show you how you can actually deploy a contract on blockchain on a local net. So, first of all, you are going to create a directory called a script. And on the script, we already create two files. One is called counter.s.so, the other is called run1.s.so. Let's look at the first one first. So the counter.s1 is actually a contract, and the deployment is actually uh, implemented by the function called run. Okay. I didn't touch the setup, but in the setup, you can also set up some initial variable, something like that. But typically, the deployment should be done in the run. And this contract need to be the inherit script, which is imported here as part of the Forge package. And in this example, I'm going to deploy a contract which is in the Open Zeppelin called ERC20 mod. So basically, it's ERC20 token with two methods exposed, mint and burn, so that you can mint or burn, because it's a market, so you can burn and mint to any account. Okay, so uh, there are a few prep you need to do. The first thing is you need to set in an environment variable, which is essentially in the in the .bashrc, set a private key there, and the private key, of course, you can look at your MetaMask and expose your private key there, but don't show that to other people. And also make sure the file should be protected using standard Linux protection. So I'm not going to show it, but typically you can use a test private key so that you can ensure that it's not going to be exposed easy to other people unless you're doing your deployment. So the first time is you are going to retrieve the private key from the environment variable, and then you're going to use the vn.addr to get the address corresponding to the private key. And then you can bring that out to take a look if the address is corresponding to the one you have on your MetaMask. And then everything is between this line, start broadcast, and stop broadcast. So in between, you could deploy a contract and call the contract. But it's very important, you need to set a private key over here. So that means whatever in between, you're going to use, in this case, John is the MSG sender. So it's like called by John, okay? Anything in between is going to be called by John in this case. So the deployment is easy. You can just use a new or use a creator two to deploy it. And then afterwards, I bring out the address. And then now I can mint to John, which is to myself, and then finished. And then finally, I'm going to print out what is the balance for John. So pretty simple. And there are a few ways to run this. The first one is of course, you are going to run this locally as a simulation. So I'm going to run here locally as a simulation. I'm going to run from the project home directory, which I'm going to say specify script and then the name of the file and then the name of the contract. So as you can see, John's address is this. I verified this with my MetaMask, and it's correct. And I also can see that the contract is deployed in this address, okay, which is 7294. I don't know if it's going to be the same address if I deploy on the real blockchain. And it's going to mean 10 Ethereum over here, 10 Ether. Okay, so the John's balance is going to be 10 Ether. So local simulation is correct. Now I could do the remote simulation, which is going to be this one. So I'm going to specify the URL, which is also going to be set up in the environment variable. In this case, it's Goerli RPC URL, but deploy on the real network or blockchain is exactly the same, except instead of using instead of using if the test net, you are going to use the mainnet. Okay, so the simulation is also complete exactly the same, except now you need to know how much gas you need to pay, something like that. So you get some idea. And then the last one is simply add broadcast to here. And then everything will be real. Okay, so now everything is going to be real. You're going to say with for receipts. So 10 Ethereum is going to be deployed. And then the deployed address is going to be here, 0x this, which is not quite, oh, actually this is the same here, but not, I think it's the same as local. So the address of deployment is not the same from local to remote, which is understandable. So the final balance is going to be same, 10 Ethereum. So that means that it's a successfully deployed. Okay. Now once it's successfully deployed, then you can run more. You know, we don't have to deploy again over here, but we could. We can still call the method, and this time we don't need to deploy. So I'm simply going to bind this local variable to this address. I don't deploy anymore because it's already deployed. But I can continue to mint another 11 over here, and then in between I use a private key. So so this part is just going to call the method and mint another 11 without redeployment. Okay, so we could do this again, but this time we're going to call, instead of a counter script, we're going to call bound1.s.so and bound1 over here. Okay, and it's not simulation, so I'm still going to do real broadcast. Okay, I need to go to a right directory. Let me see. Oh, it's not server.s.so, so it's a wrong file. So as you can see now, we have 10 plus 11. We have 21 Ethereum minted now for John. So that's it. And finally, if you want to also do deploy as well as verify the contract, all you need to do is add another option called verify. But of course, you need to set up your Etherscan API key in your environment variable as well. So that's it. So that's how you can deploy and call function of the contract between start broadcast and the stop broadcast under a script in the script directory. So thank you so much. Have a nice day.